Okay, this is a quick overview of the system development lifecycle. First section we're going to look at is the analysis section. So the systems lifecycle, or the software development lifecycle, starts off with the analysis stage. This is where somebody goes into a company or an organisation and talks to them, finds out what their problems are, comes up with some ideas for new systems, before they then go on to the design stage. Now, this isn't the stage where they're actually going to make anything. These are just where things are put down on paper so that people later on can then code the system. This is the part where it's then coded. You've got the development and testing phase, so the system is actually written, created, and it's then tested with lots of different types of test data to make sure that there's no errors within it. The implementation stage is then when the software or the system is handed over to the company, and it's the method of doing that to ensure that everything runs smoothly. The documentation stage, this is where essentially a user guide or two user guides are created, so that once the organisation that's creating the new system, or the person that's creating the new system, has left, then the company it's intended for still know how to use it. You then go on to an evaluation stage where you compare what you've done to what you set out to do, and you look at what people think of your system, and then usually this means that more problems are identified and the system starts again. So, looking at each stage individually then, the analysis stage, as I said, involves collecting information about the existing system, identifying the inputs, processes and outputs of the existing system, so finding out how it actually works at the moment, and then hopefully identifying problems with that. So people that work at the organisation may have ideas of what the problems are, but someone coming in from an external point of view might be able to identify a few more. They then also look at what the requirements for a new system would be in order to solve these problems. So it could be what the user wants to do, how they want it to look, or just, with some input from the analyst as well. So in order to do that, they need to obviously go into the company and speak to people or do some kind of research. So there are four methods that you need to be aware of that an analyst can use to do that. So the first one is a questionnaire. So this is exactly as it sounds. A lot of questions printed out usually, or on screen perhaps, that are given out to a large number of people. They then complete them and you get the results. Now the good thing about this is that you can get a lot of information really quickly. The bad thing is people might not always fill them out, or they might not be honest on them. But generally the data that you do get back is easily then to analyse. You can make graphs, you can score things. Another method is by using an interview. So this takes a lot more time. You go in, you speak to people, you ask them questions. Now, as I said, this takes more time, so that's a disadvantage, but an advantage of this is that you can be a little bit more reactive. So if somebody says something, you can question them a little bit deeper about it. So you don't have to use a set of questions rigidly. You can adapt that as you go along. Another one is observations. So this is where you go to the business, the company, the organisation, and you watch what they do on a day-to-day basis. So this again takes quite a lot of time, and also people tend to not do things as they would normally do if they're being observed. You've all perhaps been in a lesson where a teacher's being observed and all of a sudden they start singing and dancing and doing all things that they don't normally do. That can happen as well in a business. The good thing is though, you get to actually see firsthand what's going on, so it gives you a better idea of what the problems might be. Finally, you've got examining documents. This is where you go in again and you have a look at maybe their reports, their letters, their on-screen website, whatever it might be. It gives you a good idea of how the data flows within the organisation. But again, it can take a lot of time, but it does show you where all the data is, where it goes, what's collected, what's printed, that kind of stuff. So you then move on to the next section, which is the design section. There's different things that you may need to be able to design, or that you need to be able to explain needs to be designed. So the first one is a data capture form, which is a printout or a screen that allows you to input information. So it could be a form that you fill out to join a gym, or it could be an on-screen form to join the gym. You also need to design the screen layout, so this is how things are positioned on the screen. It might be menus, it could be the website, anything like that. Validation routines. This is a way of stopping data being entered into the system that is invalid. We'll talk more about validation shortly. Verification needs to be designed. Again, we'll talk about this in more detail shortly, but it helps to verify the data is accurate that's being entered. Report layouts, you've all done reports now, you've done your practical skills exam. So the report is just something that's printed out, so it's a hard copy of something, so it could be an invoice or a letter or just a list of orders. Screen displays, like a report but just on screen, so instead of printing things out, it's how things are displayed on the screen. And finally, your data or file structure, so when you create a database, you set one of these up anyway. You pick the data types, you pick the field names, that's you designing or creating a data or file structure. So in the exam you could actually be asked to design something. They'll give you perhaps half a page in a box and say design any one of these three things. So it could be a data capture form, a report or a screen display, or you might be asked to do some validation and verification methods. So obviously it's important to know what the criteria is for designing these things. You get marks for including suitable or necessary fields. So if they're asking you to create a form to join a library, then you'd need your forename, surname, address line 1, address line 2, age, date of birth, something like that. As long as you've got sensible fields, you're going to be picking up marks. You also need to make sure that you're leaving appropriate spacing. So if you've got forename box, it needs to be a suitable length for someone to either type it in or write it in. Same with date of birth, you might want to separate it out, things like that. Email would obviously be a longer box than forename, for example. If it's going to be an on-screen display, or a database or something like that, then you also need to make sure you include some sensible buttons, so a submit button, next, back, reset, that'll pick you up some marks. You also need to make sure the information fills the page, so if you're given a whole page, make sure you use the whole page, don't squeeze it into the corner like this one, make sure that it fills the whole page. You also may need to make sure you use appropriate controls for each field. So there's different controls, you can have a look at them in more detail on this website, but you've got text input, which is a text box. You've got buttons, which we've just spoken about. You've got radio buttons, which are circles. These allow you to just select one thing. So it could be which day do you want to attend, and there's 5 buttons and you just pick which one. Or it could be which days do you want to attend, and there's checkboxes. So checkboxes you can tick more than one. And you've also got drop-down menus as well, which you'll have all seen when you're filling out online forms. So this is an example of one of the mark schemes. Now it's only a 5-mark question. You get 1 mark if you give an appropriate spacing. You get another mark if you use forward and back buttons, if it's an appropriate question for that. If the information fills the page and it's clearly, in this case, a screen form, then you're getting 3 marks just for doing that. You can pick up another 2 marks just by adding 3 sensible fields in. If you add 4 or more in, then you get 3 marks, and it means that you've only got to pick up 2 of these then. So this should be a 100% question really, it's not difficult. So this is an example of what you might design for a report or a screen display. And obviously an on-screen form, we've done those in lessons, but it would just look like a sort of sign-up page to any website. So as I said, validation and verification is something else that you need to be aware of. I can't think of an easy method of remembering which one's which. It's just a case of you're going to have to remember it, I'm afraid. So verification is checking that the data being entered into the system matches the source data. So the source data could be this piece of paper over here. Someone's came into the gym, they want to sign up, they filled out a form, and later on in the day somebody that works for the gym types that into the computer. And it's making sure that what you've written here ends up being what's on the computer and there's not any transcription errors as it's being copied across. So there's 2 ways of doing that. One is simply visual comparison or proofreading. It involves reading what's been typed in and comparing it to what's on the source data. Could be done by the same person, could be done by somebody else. You've also got double entry of data, so the same data is entered twice and it's only accepted if they match. Now you've probably seen that when you have to type in a password. You end up typing it, you have to type it in twice usually, and that sort of verifies that you've typed it in correctly. You know, in a big company that's typing up important data, perhaps medical data, they might have 2 people typing in the same data, and then if they don't match up, it's obviously one of them's done it wrong, and then they both have to type it in again. So validation is the other method that you need to be aware of. This is a check that's performed whilst the data is being entered. So as you're typing it in, it's checking that it's valid. It makes sure that the data is sensible and reasonable, and that it fits within certain rules. So it could be that we only accept people with an age 18 or above. Okay, so it would reject the number 17. So on to testing then. When you have created the new system, you then obviously need to test it to make sure that everything works as it should. So the things that need to be tested are the data or the file structure. So you're going to have to make the tables, you've got to link the tables, you've got to create your validation routines. You might have different input methods, so it could be that you just want people to type it in on a form, it could be a web form, it could be a barcode scanner, lots of different methods of inputting data. You then got to decide what your output formats are going to be. So it could be reports or screen displays, so they all need to be created as well. So then, once they're created, it's got to be tested. What happens here is a test plan is created, and this is then used and followed quite rigorously to test the database does, or the website or the spreadsheet does exactly what it's supposed to do. So when you're doing the testing, there are 3 different types of test data that could be used. So if we use this scenario as an example, so we're only allowed numbers 18 to 100, maybe it's somebody's age or something like that. So when you're testing this to check that this validation works, you need to use 3 different types of test data. So normal data is something that should be accepted. So a number between 18 and 100 that's usually in the middle, so maybe 50. Abnormal data is data that is outside the range, so perhaps number 6, or the wrong data type, for instance. So if you type in the word fish, then it's obviously not going to be a number between 80 and 100, so it should be rejected. That's abnormal data. And then finally, the one that people tend to forget is extreme data. So this is data which is on the boundaries of the range, so it could be 18 or 100. It should be accepted in the system, but only just. So in this case, 18 and 100. So this is what a test plan would look like. You've got your numbered tests down the side. You've then got a description of it, possibly saying what type of test it is, normal or abnormal. You've then got the test data, so what it is that you're going to type in exactly. And then you have to calculate an expected result. So should this be accepted in the system? Should it be rejected? What should the result be if we're adding 18 and 100 together? So that would what goes in the expected result column. And then once the testing has been carried out, this column's filled in. It could be a tick, yes it's met this, or it could be a cross, no it allowed the number 6 to be entered, and then obviously those errors can be fixed. So implementation, as I said earlier, this is where the system is handed over to the company and they install it essentially, they start using it, and there's different methods that they can use to do this. Now the first one is direct, so on a Friday night everyone goes home using the old system. We'll go with the school example because it's something that's ongoing for us at the moment. So we're always using ePortal to do your registers, to do your reports, to do all sorts of things. On a Friday we stop using that, and on the Monday we start using the new system, which would be Go for Schools, and that's it. We never use ePortal again, we only use Go for Schools. Now obviously the advantage of that is it's very quick. It took no time at all essentially to swap over, but it's quite risky. If all the teachers type in their reports for every single student and then it doesn't work, then they've lost everything. They can't go back to the old system. So it is a bit of a risk. Parallel, this is where you use both systems at the same time. So we'd be running ePortal and we'd be running Go for Schools. Now this obviously means that staff have got to do things twice, which takes a lot of time, but it is very reliable because if the new system breaks, you can easily go back to the old system and you've lost no data whatsoever. So phased, this is the one that we're currently using within school. So we start off using ePortal and eventually we start taking sections of that away and use the new system to do that. So it started off where we would do reports on the new system, and then student data was put across, and then working at grades, and eventually the old system stops being used entirely. I'd say we're down here perhaps at the moment with the school, but eventually ePortal will probably disappear completely. So pilot, this is where essentially you risk sacrificing one area of your company. Now, it could be a branch, it could be a department. So one branch, so branch A we'll call it, or the English department, they use the old system on a Friday, new system on a Monday, and they test out for any errors. If it crashes, okay, English have lost all their work, but it's not affected the whole company. You then possibly try it in another department before the rest of the branches are all adapting to the new system. So, they all exist for a reason. different scenarios will call for different methods. So when a quick changeover is needed, you're obviously going to use a direct method, and where there is a low risk, direct might be used as well. So if it doesn't matter if you lose a day or two's worth of data because you're a small company and it's not the end of the world, then you might want to just quick change over and use a direct method. So when the cost of doing the work twice is not a problem, then you're going to go with parallel. So if you're using the system very limited and it's not going to be too much trouble to do things twice, then you might want to go with parallel. The same when you can't afford to lose any data. If this is something that would be catastrophic if you lose the data, then you're going to have to do a parallel implementation. So when time isn't a concern, so you don't mind if it takes a long time, then you could use any of these. You could use parallel, phased, or pilot, because you could run parallel as long as you need, phased could take as long as it needs, and obviously pilot you could try each department for longer. When there is a risk, again, you could use these same ones. So these all have some backup. So parallel obviously has a full backup. Phased, you're only going to lose the section you're currently working on, and pilot, you're only going to lose that one department or branch. So documentation, there are two types, as I said earlier. One is technical and the other one is user documentation. Essentially, the exam board have produced a list of things that they say is included in each of these types. So the purpose of the technical documentation is to help the programmers or analysts make improvement to the system, or repair the system, or maintain the system, and these are the things that are included in it. I'm not going to go through them all, just pause it and have a look. This is everything that is included in the user one, and this is to help the users of the system learn how to use it. Now the type of question that come up is they could say, name 4 things that are in the user documentation, or it could be name 2 things that are in both, or name something that's in technical that's not in user. So unfortunately it is a case of just learning as many of these as you can. Some of them will stick in your heads easier than others. Just do what you can with this. They might also ask you to explain why that we have these 2 types of documentation. So you can say that the technical documentation has to be produced for the analysts, because without it they wouldn't know how the system works. And then if they don't know how it works, they're obviously not going to be able to update it or improve it, or repair it. The user documentation is needed to be there and phrased in a way so that someone that isn't an expert, so that someone that's not a programmer or an analyst, can understand what's going on and they can actually operate and use the system. So that's what you need to be saying if they're asking why we have the 2 different types. So finally, evaluation. So we've created the system, we're now checking whether or not it meets the needs that we set out to solve. So after it's been implemented, it needs to be evaluated, identify 2 different evaluation strategies, and explain why they're needed. So one strategy could be to compare it to the original task to ensure that they've been met. It could be to identify any limitations or possible improvements, so that it works without problems. Or it could be that you're going to go and collect data from the users of the new system to see how they're coping with it, or to see how well it works and see if anything needs changing. Or another strategy is that you could speak to users to find out how they're getting on with it again, so that their needs are taken into account. These 2 are very similar, so you might want to just pick one of these 2 so you don't end up crossing over with what you're writing. This one's about collecting data, this one's about speaking to them, so maybe just pick one of those if you're going to talk about them. Okay, so that's everything in a nutshell. Obviously you're going to need to know that in a little bit more detail. There's plenty of practice questions out there for you, but that's a quick summary of the system development lifecycle, or the software development lifecycle.